Now coming to, we have already seen about hash set. So today we have the topic that is called linked hash set. Okay, so we have seen about hash set, how the data is being stored. But let me show you again in the debug mode. Then only you will understand the linked hash set. Basically, if you see the hash set, the basic properties of hash set, it is saying that it doesn't allow duplicate. Internal implementation is map. Okay, it is non-synchronized. Insertion order is not maintained because, like, with the help of hashing technique, the data storage location is calculated, and based on that, indexing position is determined during runtime. Okay. So basically, these are the hash set properties. One you can add, like, hashing technique is applied, and it is non-synchronized. Non-synchronized, it means it's bit faster. And one more additional thing, you can say that one null is allowed, because in collections we have some places restriction about nulls, that some like classes are allowed with nulls and some classes are not allowed with nulls. Like in linked list you have seen, or whatever the array list you have seen, even duplicate nulls are also allowed. So that was the property of linked list or array list. But in hash set, if you go, one null is allowed, duplicate nothing is allowed, means you cannot have like duplicate same kind of values. And it is generic. When you are defining generic is what? Means E type you are defining, then it is becoming a particular type of data storage. If you are not defining E type, then it's like you can store anything. Yes. Integer, character, string, anything. It's up to you. So we have linked hash set, but before going to linked hash set, I have one example which I would like to show you. You can see here, this we have a book class and book type like data, because earlier we have seen a string, you have seen integer you have seen or not, like let me show you integer. You see here what I have defined a set of integers. So you have set of integers, then you are adding like integers value, and one null is allowed. So like null is everywhere, you can add it, and then you run it, and then you can check it. You can see here it is normally coming in the sequential order, because like indexing is calculated on the based on what you call numeric value, and then hashing is generated. So that is like by default you will see it will come in the some ascending order. So if you want to check, then you can run in the debug mode and you can check that how the value position is organized in ascending order, something like that. See, a random order we have set up, and null will always become on the first position. That's the main thing about hash set. Just remember this, okay? So this was some example of integer, and now we have example of data type, object, custom defined data type. So for that, I have a book class. First, look at the book class. Okay, what is in the book class? I have three variables, not three variables. It has more variables. One is ID, one is name, author, publisher, integer, quantity. So this is the way of creating multiple data. This is something new for you. Line number 6, you can see we are creating three variables with the same data type. So you can create like this as well. So we have integer ID, integer quantity, and like that. So you can put it like that, maybe, comma, and you can delete this. So you can see here in 2 lines we have organized everything in ID and quantity, then name, author, publisher. And we have getters and setters method, not setters, only getters methods we have defined. You can see here. So getter methods, why we have defined? Just to read the value, because the purpose was only to read the value. So whatever the variables are there, whatever the value they are holding, I just want to read it. So you know how to create the getter method. So we have already created getter method, and we have two constructor. One is default constructor and one is parameterized constructor. You can see here. So in the parameterized constructor, I am passing ID, name, author, publisher, everything we are passing, quantity. And based on that, the local variable and the class variable. You're just assigning it, like quantity is assigned to this dot quantity, publisher is assigned to this dot publisher. So everything is assigned. It's just to initialize the value. So this is for your information. And we have a toString method. So for toString method, I have to tell you one thing. There is an object class in Java. Let me write object, then I can define it. You go to this class, you will see a toString method is there present. And by default, it is printing the memory address and with the package name and class name. Normally, this is the by default structure of toString method. You can see here, it is printing class name, means whatever the package name and class name will be there. Then at the rate symbol will be there. And then it is calculating the hash code of that particular. So hash code will give you the memory address in the hexa. So it is calculating the hexadecimal thing. So it will give you something random order like any integer character combination. So like that into hexadecimal format it will give you. So this is something internal implementation, but you can override it. Override it means like in the particular class, if I want, I can just write my own code. So what I have done, the toString method I have overridden. Overridden it means like I have written my own code. And here what I'm doing, return in this format, I'm printing first ID, then name, then space author, then publisher, and then quantity. So these things I am printing. It's up to me how I want to design. So this is something design I have created, and this way it will, when I will print the object, it will actually when you will try to print object. So in the system.out.println, this method is automatically triggered. So whatever the code is written, that will automatically execute. So this is something internal structure about the book class. Now I'm going for the implementation. So where I have implemented it. So you have already seen that hash set example for integer, string, everything. Now I have the hash set example for the book data type. You can see here. Let me close other things. Close, 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 close. And I will open it side by side so that you can understand it in a better way. So we have a book class and this is something implementation. So implementation part, it is saying that you can make any generic data type. So it means like now this hash set will always hold the data of book type. Means integer string you cannot directly put over here. Whenever you want to try to store data, it will ask you that this is designed for only book data type. So this is something restriction you are putting here. And based on that, you have to first create the book type object and later on you can add only book data type. You can see here. So it is saying now book data type because we have defined here generic as a book. So it will only take book data type. So see here how I have created the object. First I have created B1, B2, B3 and B4 and I'm invoking constructor. So new book and I'm passing that the values. So you can see here in the constructor first I have to pass ID, then name of the book and then the author, then the publisher and the quantity. So how much quantity I want to buy. So like this, I have B1, B2, B3 and B4. Four books I have, four book data type I have created. And after that, I want to store in the hash set. So for adding it in the store in the hash set, I am adding just add method. So B1, B2, B3 and B4. So like this, I have passing here. So first I have to create the object and then I am passing here. And after that, when I want to print it, so there are two ways of printing. One is standard way, means this is the standard way. And if you have overridden the book toString method, then you don't need these things. This will automatically be done because I have already written that code in the book. You see here, the same code I have already written over here, return the string type. So when I will just print the object, it will automatically print it. So no problem. But let me show you. Later I will show you the example of this toString. But just I am showing you that I have written the logic that how to print it. So traversing has said this. I want to print all the values. So what I am doing here, book data type. This is the name of what we call my collection. So collection is here. The data type is here. You see here data type I'm taking here, and this is the local variable. Means I have just taken B as a local variable. So B dot ID means first it will point to this one B1, then it will point to B2, then it will point to B3, and then it will point to B4. So I'm just using B dot ID, B dot name, B dot author, B dot publisher, and B dot quantity. So it will iterate and it will print for everyone. So let me show you. Right click, run as Java application. You can see here it is printing everything. So why it is printing like this? Because this way I have defined. But if you want to use toString method, because you have already overridden it, so let me comment this part. Same thing almost I will take. And instead of this long code, I will just use a short code, because most of the things I have already done over here in the toString. So what I will do here is out. And this is the local variable. When I will print this, it will print everything. ID, then big bracket, sorry, equal to greater than symbol, then name, everything it will print. You see here. So what is the difference between this and this? Because this is calling the toString method, and this I am directly printing everything. So here you have to write the logic, and here the logic is hidden. I am hiding the logic where? In the book class. And when I will try to print, it will just print everything. So let me run this and show you the difference, or to make the use of toString method. So when you try to print the object, basically it triggers the toString method. Okay. And if I comment this, so you see the output, how it will give you. Then it will call the toString method from where? From the object class. If you will, override method is just commented out. And if you write, if you try to run this code, then it will call the method from the object class, and you see the output will be like this. So package name, then the class name, then at the rate symbol, and the memory address. So by default, toString method is printing like this from the object class. But if you have overridden, then you will call this method. You see here how it is printing everything. If I put double equal to like this, so you will get the output like this. You can see here it is printing as expected what I'm giving. So I've given the big bracket here, and then I'm closing the big bracket like this. So it is printing in the same fashion. You can see here, right? So it's up to you. By default, when you are printing any object in the system.out.println, you will pass any object data type. So it will just print the address. That's it. Just remember this. Okay. So this was something example of hash check. And if I will see more examples, integer already have shown, object data type also shown. This is a string data type also we have seen. So I think hash check we have already completed most of the things. Now let me move to other things. That is linked hash set. So you can see here linked hash set. But first you have to understand one thing before proceeding to the linked hash set. Let me open here linked hash set, and one is hash set. This hash set example. This was object. This was normal. Okay. Let me take a string up. Then you will understand. So I'm just running in the debug mode, both toggle breakpoint. Okay. Whatever the things not needed, I'm just commenting out because I have to show the demo. Okay. Size and just shade I will print out. So let me run in the debug mode. Right click, debug as Java application. So it came here because the debug point I have put here. So it is just waiting for the next line. So I have started the execution one by one line it will go. So you see here, first it created like this. And basically it is a map structure as I already told you. And how this is being stored, you can just keep on watching. So you just focus on table. Table as of now is null. But once you added the first one, okay. So now table is initialized with the size of 16, can see here. And in the seventh position, this value was stored. The ONE was stored on the seventh index position. So 0 to 7, eighth position it is indexed. And you see here, it is internally creating hash map. So hash map you will learn later, but just basic idea I have given here. You can see here, it is storing like this. Once you expand number 7, you can see how it is being stored. So first it holds like node, it's basically node 1. So node 1 is stored like 4 values, hash, key, next and value. The value is what? Means like it will hold the value. If it is like value you have whatever pass. And key is something like the value you are passing here. So ONE1 you are passing here. And by default, since it's a map structure, so by default, every time it is just passing object. And yesterday I have shown you that by default, they have created a present object. The name of object is present. And that object is passed every time when it is going for value. So it has a key, it has a value, it has a hash, it has an X. So node structure is something linked list kind of thing. So one by one, it will point to the next one. Okay. Now I'm going to next one. So it stored this time here. You can see line of index number 13. Then I'm going for next. It will be highlighted for some time. You can see now 14th position is stored. So 4 values so far we have stored. You can see here 3 values. Somewhere I can see that there are 1, 2, 3. 4 is stored where? Somewhere it is stored, but I cannot find it. Maybe it is duplicate here. You see here next it is pointing, right? I think it is stored here. You can see here on the index number 7, 2 values are there. One is 1 and one is 4. So like it is pointing to the next one. You can see here. Next is pointing to this one. So this way it is creating a node here and then it is pointing. Sometimes it will happen. So it's very interesting to see here. So now it is stored in the different index position. 5. So like this, you can just try to execute one by one and check how many nodes it created and how many size it created. The total size is what? Size is 16 values. And finally, what is the capacity? You just analyze it once. Capacity becomes 32. Once it comes to the last one, then you can click on this one, resume. Okay. And then you come back to the Java mode. So this was something node base. Hash map node base. Okay. Now I'm coming to the linked list. Linked hash shed. So linked hash shed is something what? Basically, you see here, it is the child of the hash shed. Come here and see this structure. It is the child of hash set. And the basic difference between hash set and linked hash set is linked hash set maintains the insertion order because it works on the it works on the linking technique. This node is created and it creates the node, and one node is storing the address of next one is storing the address of next one. So same like linked list you have seen in the past, but since it is hashed, so it is internally managing linked hash map. Just remember this point. Hasset was maintaining hash map, but linked hash map is maintaining linked hash set is maintaining linked hash map. So basically, when you will see the linked keyword, so you can understand it's a node application. It's node basis. It will store the data. So one node will be there, which will point to the next node, and next node will point to the next node. Next node will be point to the next node. Okay, like this kind of data structure they are created. So it's a singly linked list. Basically, singly linked list is what? One node is pointing to the next one. So from next, you cannot come back to the first one. So that is the main drawback of singly linked list. So basically, it is internally maintaining singly linked list. You can see here, node-based application it is creating when one node is created and it is pointing to the node next node. So if someone will ask you how link hash state is maintaining the insertion order. So you can tell that basically it is internally creating a link of nodes. Okay, what link of nodes? So one node is pointing to the next and next is pointing to the next. So in this way, it maintains the insertion order. Okay, like not like hash map, what it was just calculating the address and then it was generated. So I will show you once I will execute. Let me come back. Let me store it here like. Let me toggle the point. Okay, so once I toggle the breakpoint, then I can execute it in the debug mode. You can see a same kind of data structure I have created here, but I will show you first. I will show you without debugging, then I will show you in the debugging mode. You just need to focus how data I am inserting and how data it is printing. It's just a simple demo. But the basic difference comes in the internal implementation. You see here how I have stored the data and how I am printing the data. So 1, 2, 3, 4, some same like that it is coming. And you see the last value, it is coming as a 7.5. So this is something interesting, but how it is being maintained and what are the other methods? So let me open this class first. Very few you can see here methods are present here. So these are constructors, linked hash rate, where you can pass the initial capacity and load factor you can point. So these kind of things they have given, no additional methods they have given. You can simply proceed with the example and check in the debug mode how the data is being stored. So right click, run debug as Java application. It's here. As of now, this line is not executed, so no data is being stored. And I'm going to execute. So once I execute, the name of the variable was linked hash set example. So it created. So it is also creating a what map. But what map? Linked hash map. Earlier it was coming up a hash map, but now it is linked hash map. So internal implementation is what? Linked hash map. And the table is created. As of now, the table is null. Threshold is 16. And the threshold is 16 means you have to fill the 16th position. Then it will grow up something. Load factor is 0.75. Initial capacity is nothing, but once you added first object, then you can check. So let me add the first one. So something will change here. You can see one linked hash set should be created. But the capacity is 16. You can see a table is 16. By default, null, 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 everything is null like that. So let me expand this. And what are the other values are? You can just have a look over here. So map is having access order, entry set, head. Head is normally pointing to the first node. Okay. And one is tail as well. So tail will point to the last node. So there are two important factors which are to check whether if head and tail is the same, it means there is at least one element. If head and tail both are null, it means there is nothing there. And like normally head will point to the first one and tail will point to the last one. So this is something important point for you. The load factor is 0.75. Capacity is 16. Initial capacity is 16. You can see here how the initial capacity is being created from 0 to 15th position. So as of now, I have just added one. So it is coming on the 7th index position. You can see here insertion order, it will store anywhere, but printing order, how it will print based on the next, it will start printing. So head will give you the first data and then first data will give you the address of next data. So in this way, it is being stored and accessed. So that is for your information. So let me execute couple of values, then you can see how the data is being stored. So let me go with one value and you see here internally how this value is stored. You can see here one is key, one is value is object. Always remember this because this is internally a hash map where key is there and value is there. The value always will be object for what? Linked hash sheet. In the case of set sheet. Okay. So key is there and value is there. So key is the key which you are passing here and value will be by default object. And next is pointing to the next data structure. Means suppose that it is linked to the next. So it will just point to the next. Because I told you this is a singly linked list. Singly linked list means you will access one node and via one node you can jump to the next node. So next node will be there. So next is pointing or giving you the address of next node. So you get the address of next node and then you go there. Then 1 is in 4. Both are at the same index location, 7th. So this is something internal structure. Somehow you can get some idea. Hash value is there, key is there, next is there, and the value will be there. So before is there. So before is also there by default. These things and after is also there. So you can see here these basic fields are there. Means if no one will ask you in the interview, this is for your concepts that how the internally data is being stored. So let me keep on storing the couple of data. And now we have a fair idea that how the data will be printed. So when the printing time will come, it will access the first one and first one will give you the address of next one, then it will keep on printing. Because in linked, what you call, array list, linked list, you have already seen how the data is being accessed. So it was maintaining the doubly linked list, but here it is not maintaining doubly linked list. It is normally maintaining singly linked list. You see here before is always null for any data. So 7th position, if I go to the next one, so before it is having, yeah, I think yeah, it is having. Once the node is same, now node is same, then it is having before. Because 7th position, two values are stored. One is 1 and one is 4. So then in that case, it is having that value. You can see here. So next is pointing to the 4 and 4 before is pointing to the previous values. It is pointing to the other values. You can see here. In this way, data is stored here. So let me just execute and show you. So finally, our linked list is completed, and then when you are printing here, it is stored. The insertion order is maintained in this way. Normally, hash set doesn't maintain insertion order, but linked hash set maintain the insertion order. In the interview, when you will say this point that hash set doesn't maintain insertion order. Then the interviewer will ask the cross question. Which class in hash, it's like set implementation, maintains the insertion order? Then you will tell that linked hash set. Then they will ask the cross question. How? Then you have to tell basically it's a link of nodes, and our insertion order is maintained on the basis of nodes. First node address is stored, and based on that the next node address is pointed out during runtime, and in this basis it is going to store. It is going to print. Storage wide, it can be anywhere random. You have already seen it, not sequential accessing or sequential storage is there. Randomly it is taking any place and storing any value. But during runtime, your head will give you the address of the first one, and then it will give you the address of the next. So this is something very, very important. One head is maintained, one is tail is maintained. Tail is maintaining the last value. You can see here. So this was the last value, 75. And head is maintaining the first value. So head is 1. Head is pointing to the 1. So these are the basic informations you should have, or anyone should have who is working on collections classes. Let me complete the execution, and then I come back to the normal Java execution. So now you understand how these things are being done. So since it is the child of what you call hash set, every methods of the hash set is already applicable. So whatever you have seen, you can just use or try anything, whatever you have seen. Like you can try removing this and check whether it is working for it or not. You can see here, I'm just using remove method. And after that, just for demo purpose, I'm showing, because you already seen in the linked hash set, no other methods were there. But don't worry, if it is not there, it's whatever the parent methods are there, you can check. It is already available. If I am running this, and you can check whether it is giving you the updated output or not. So in the first list, 1 was there, but in the second list, it is not there. So in this way, you can just use it. That's it for about like linked hash set. The only difference is that it mentions the insertion order in the linked hash set, and basically how insertion order is maintained. It is maintained based on the linked structure of nodes. Link of nodes it is creating, and then it is on that basis it is maintaining the insertion. Basic properties are same, like it is maintaining the linked hash map. You can tell this one hash sheet internal implementation is hash map, but the linked hash sheet internal implementation is what? Linked hash map. Okay, so linked word is already associated with this. So non-synchronized duplicates are not allowed, only uniques are allowed. So these things you can tell. Okay. Anyone has any doubt? Anyone?
Yeah, Rajiv, one thing about the address. So the when we're doing this debugging, so the nodes are having address of each other, right? The next node, when next node is created, it has the address of previous node, and previous node should have address of the next node.
Hmm.
Okay. Okay. And this is what I wanted to understand.
This example should be there. Right click, refactor, collections list. This is about This is about hash set collections set map demo. So if you are clear with what you call linked hash set, then I can proceed further. Or anyone has any doubt, they can ask.
Yeah, we can proceed. I think.
Okay. So now we will come back on the complex topic, which is, you can see here, this is one page only, right? But this is going to take 3 classes. Just mentally prepared for that. So one is comparable and one is comparator. So comparable was introduced in Java 1.1. Comparator was introduced later. Okay. So this is from the Java lang package and this is in the util package. So util package, all such things came in the later 1.2 version. But like normally Java 1.0, when it was introduced, then there were some basic things given like comparable. So basically comparable is an interface which provides you this compare to methods. So compare to methods, what it does, it compares two objects and returns 3 values. Okay. Just remember only 3 things. Either it will return 0 in the case of both objects are equal. It will return negative value if the second value is greater. And if it is returning positive value, it means first object is greater. So like this, it is comparing. So what you have to do, you have to compare one object with another, and based on the comparison, it will subtract some what you call numeric value of that particular object, and then it is calculating and subtracting, and then finally giving you 3 values. So either it will give you 0, either it will give you negative value, either it will give you positive value. Only 3 values you will get by default. So this is the compare to method. Yes. And it is present in the comparable interface. So this is high level logic, but how to use it, you will see in the real implementation. So basically comparable interface provides you the compare to methods we return 3 values. But based on 3 values, we use it where? Means what is the use of 3 values? So we normally use these 3 values in the terms of sorting. So sorting is based, means left and right is compared, and based on that it is sorting, and then it is like it is comparing first, and it is these values are used for sorting techniques. Okay. So you can see here comparable is interface provides a single sorting sequence. Single sorting sequence means one time you can use sorting on any one object. Just remember this. One time you can use sorting on any one technique. Means not, you can see not on the integer, not on the string kind of data. Don't think of those perspective. Normally when you are using comparable, it means you have an object and you want to compare on multiple fields. Consider that you have 5 students, okay, and you want to do the sorting on the basis of name, or you want to do the sorting on the basis of date of birth, or you want to do the sorting on address, you want to do the sorting on name, you want to do the sorting on roll number, like this kind of data. Considered in that scenario, it is very much useful. Normal integer, string, all those things, collections.sort is capable enough. But when you are using object data type, so what you have to do, normally object data type is not able to do the sorting. Then what you have to do, you have to use comparable interface, and based on the comparable interface, then the sorting technique is applied on a particular data type. So first I will show you without any sorting technique, you try to sort a data, then what will happen? And once you apply the sorting technique or like use the comparable interface, then try to use the sorting, then you see what will happen. So see the difference, then you will understand. And second version is like this is child and this is the father. Just think of that. Means it has some basic capabilities and it has advanced capabilities of comparing the objects. So runtime comparison, and like it gives you more flexibility. So if you are already knowing comparator, so no one will go and use the comparable interface. Comparable was very basic things, but comparator is something advanced level. Not advanced, I can say super advanced level, means something very interesting to learn. You see here, it means a default natural sorting order. Comparable affects the original class. The actual class is modified. Comparable provides compare to method to sort the elements. Comparable is present in the java.lang package. So these are the basic high level theoretical things, but let me show you practically how I'm going to implement. So let me go comparable and comparator. You can see here, I have comparable and I have comparator. Two things already there. Which one I should pick? You see here, first I will show you that I want to sort it. Okay. Then let me do Control C, Control V. I'm using a student, removing all the sorting things on it. My class name is this, a student sorting demo. So this is my constructor. Now think of a scenario that I want to do sorting on sometimes roll number, name, age. So how I'm going to do that? So let me go to the implementation part and I will copy this, paste this. And my but I'm doing for a different thing. That's why I'm renaming, preparing something demo for you. Instead of a student, I need student sorting demo data type. It's almost same. Okay. Everywhere I have modified. So no worries. So now I will only open the things which are needed. And you see here, I'm getting a compilation error. The line number 24 and line number 26. So what it is showing here, the method sort list is a type of collection applicate and not applicable for the arguments. Okay, so that is not allowed. This is something restriction it is provided that if you want to do sorting, it will not be allowed because what I have done, I was having a student class and I am having a implementation class. Basically, I want to sort. Okay, so first what I did up to here, everything was okay. It is allowing me to create the data. It is allowing me to store the data. Up to storage data, there was no problem. But once I applied to the sorting, it is not allowing. So sorting is not allowed. But for printing, it's okay. Whatever the value I want to print, it will print. You see here, it is printing. So it will print in which order? In which order you have stored because it's an array list. So it will first, whatever the value you have stored, it will print in the same order. So 101, 106, 105, 104, 108. So sorting is not allowed. You can see here when you are trying to use collection sorting, it is not allowed on the custom data type. Means whatever the data type you having, on that it is not allowed. Normally integer is allowed, string is allowed, so everything is allowed. But since it is array list of what custom data type, so it is showing error that it's not allowed. Okay. It's showing that if you typecast it like this, then probably it should allow. Again, not allowed. Again, it is compilation error, means it's not allowed. So you can think that how do you do the sorting? Suppose that I want to do the sorting on sometime roll number, sometime like name, sometime the marks or age. It is this. So on the basis of age, I want to do the sorting. So how I will do that? That is not applicable. So to give the solution of this problem, they have given the interface called comparable. Okay. So now the comparable interface is coming to the picture. You see here, almost same thing is there, but I will take different example. This is a student example. So first just look at the design part, how you will go and complete the design part. So one time, one field you can use for sorting. So first line you have to see carefully how I'm going to write it. The design part. Class student implements comparable, and on which data type it will be applicable? Only for a student. student, student. You see here, this is something very important for you to understand how you are going to write the implementation part. Implements comparable. So comparable is an interface. You go there here and you look into the outline of that. So only compare to is there. Okay. And which it is saying that you have to override because it is the interface, right? Interface method is an abstract method. And what you have to do, you have to write the logic in your implement classes. So I am just going to create a custom data type, which is a kind of a student or employee, anything you can take, or book you can take, anything you, it's up to you. What I have three fields: roll number, name, and age. Three fields I have. I have a constructor, which is parameterized. I have a default constructor, and I have a compare to method. You see here, if I don't write it, it will ask you that go and write it. I'm getting a compilation error. It is saying that add unimplemented method. So in the comparable interface, this method is an abstract method. So what it is showing you, go and write the logic because you are using interface. So in the terms of interface, it is going to ask you to write the logic. The same thing I am doing for compare to. So this time I have written the logic on the basis of sorting what? I will activate line number 28 because it is the shortest way of writing the code. Okay. You can see here, I have a compare to method. Just ignore this part. This is something next level, just basic level. What you have to do, one line. Return this dot roll number. Okay. That's the global one. And then you are going to compare with some value. I think it should be first position. This should be here. And ST should be here. Okay. So original and the value which is coming, you have to compare, and roll number of the first will be subtracted from the second, and whatever the value will become, like it will just return. So just remember, it will return only three values. If it is equal, it will return 0. If it is this is greater, this is smaller, it will return positive value. If this is small, this is greater, it will return the negative value. So like this, it will just return it. And this value will always do sorting on roll number. Okay. So this is something one by one I will show you. This is roll number and I have written the logic of compare to on the basis of roll number one. That's it. Now I'm going to what you call implementation class. So we have implementation class. What I have written, I have created the array list of a student. This is the first line. Let me open side by side, then you will understand in a better way. This is the design part and this is the implementation part. So in the array list of a student data type, I have created one array list. So up to here, it is okay. There's no problem. And I have created 1, 2, 3, 4, 5. 5 student type data. This is also no problem because this constructor will be activated and it will just assign the value of 5 objects S1, S2, S3, S4, S5. Then what I'm doing, I'm adding these values over here in the array list. This is the array list. I'm just adding add a student data type added. You can ignore this line number 24 to 29. This is something one more label. Instead of writing so many lines, you can just write in one line. Okay. So like this, you can also write it. Anonymous object creation. But you can just ignore that. And here you see here, I'm not getting any compilation error. So why? Because the comparable interface is already implemented for a student data type. So when I will pass the array list of a student data type, so now it is okay to do the sorting. And once you do the sorting, then if you print, so this sorting is only applicable on the basis of roll number. You can see here. So it will do the sorting on the basis of roll number. If I am printing this after sorting, you can see. But first, let me print before sorting, then I will print after sorting. Let me run this. You can see here the original value which I have entered 101, 106, 105, 104, and 108. And after sorting, this is the value coming. So let me put a separator. Let me run again. Someone will ask you, no, it's okay. I want to do the sorting on which one? Age. So what you will do here? You will just comment this and activate the age one. Let me do it here only. I will comment this part. And the interesting thing, I will show you one more thing. Here only you can control the reverse sorting. So this one you keep first and then you keep this value at the second position and do the just minus operation. And if you run this time you will see that how it is being sorted. You can see 11, 23, 27, 29, 40. But if you want to do the reverse sorting, you can just do the copy here. Comment the first one. And I just want to show you something. Put this here and put ST here. So this will do the reverse sorting. You can see here output. Same thing, like you have integer data type, you want to do the sorting on what you call marks. So let me do on the comment, first comment it out. Let me do three test. This here is ST and it is a roll number, right? This will do the sorting on roll number. But if you want to do the sorting on reverse order, so you just change the order. Copy, paste, comment this, not needed. ST you post here and this you put there. Sorting logics you have to think and write over here. Just right click or run as Java application. You can see here this sorting. Now you will ask you, someone will ask that, okay, integer we have seen there are some complexity in float and strings. Okay, so how you are going to do that? Because integer value it is always giving, right? So how you are going to do that for the float and strings? So first I will show you on a string and the same logic will be applicable for float as well. Just don't worry. So I have one example over here. You can see that how I'm going to use that. So let me comment this because only one compare to method will be there. You cannot have two compare to methods in the same class. So for a string data type, you can write like this. Okay. You can see here. So this is something, the first variable, this dot name, and then compared to st.name. So this is the method coming and this method is present already in the string class if you remember. Okay, if you remember in the string class, because this is a string data type. If you go to the string class, you already have this compare to method. If you can recollect that the topics which we have discussed in the string class, we already have the compare to method C A B C D compare to method. Can see here. So the logic is almost written as the same thing you can see here. So what we have to do, you don't need to write the logic again. You just need to use the logic. Simple, very simple. You just need to use the logic. So what I am doing here, I am using the same method that this dot name dot compare to. I'm not using minus symbol over here because minus will not work for a string. So I'm using compare to and then st dot name. So st is there, then dot name. Only in place of minus, I'm using dot compare to method, and this will do the everything. So this time it will do the sorting on the basis of name in the ascending order. So let me execute, right click and show you the output. Ajay, Jay, Rai, Vijay, Jai. Can see. But if you want to do in the reverse sorting order, so you have to write the logic over here. Just flip it. Comment it. And on the basis of this, you put ST. And on the basis of ST, you put this. Then just right click here and execute it. And you can see the output is just reverse. So this is something for the string. Now I have a very good example for float data type. So consider that or will marks. I will take marks. Float marks like this. So consider request. Now I have four variables over here, and here also I have to pass some values over, like 66.7. I'm putting over here, copy, then comma, then paste. 78.4, then comma, 74.9, then comma, 99.5, then comma, 59.5. Okay, so it is a float data type, so I have to put F as well. I could have taken double, that should be okay. Just I have to put additional kind of thing. You can see here I have. Now that error is gone, and once I will just execute it, it will just show you on the basis of what are the value you have given. So let me execute it. Here I have to do one more. Plus space T dot marks. Same thing I will copy here. I will paste it here. As of now, I'm not done anything on float. Marks data type. Will not consider that. It will just do the sorting on this one. Which one it is there? Reverse sorting. So reverse sorting it is doing. So let me do it for marks. Now compare that. I have one marks data type. I want to do the sorting on the marks. So how I will do that? I will take a marks. You can see here this logic will be applicable. So there are other ways, and this is the third way, and which is something like it can give you the solution of any complex thing. So you can use it sometimes when the solution is exactly not matching. I will take marks here. Marks, everywhere marks, 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 then this. I can say that this dot marks, that should be okay. This. You see here what logic I have written first thing, think of that. First condition is that if this dot marks is equal to ST dot marks, then return 0. If this dot marks is greater than ST dot marks, then return 1. If this is bigger, then just I'm returning any positive value. So any positive value you can return. It's not like 1 only you can return, any positive value. So I'm just returning 1. It's up my wish. And in the third case, it means this marks is smaller and this marks is bigger. Just I'm saying that return -1. So it's up to you how you want to handle it. Okay. Because the return type is integer. So if you return something original value, so what it will do, it will only take the decimal before the value before decimal. The other parts will be ignored. So that's why I have to write the logic like that. So this is the best logic. And if this and this logics are not working, so you can try this logic. Okay. Really, this is the best one. You can use it like that. But if this is not working, then you can also use it like this. So now we have something for marks, and this is going to sort the marks on the ascending order. Just remember this. This will do the sorting on the basis of ascending order. If I execute this, you can see here, it is going to 66, 74, 78, 89, 99. If same thing you want in the reverse sorting, so I will do copy. I will do paste. This I will comment it out. Replace this I have to change. That's it. Right click, run as Java application. So the whole logic will be changed. You can see here. In this way, you can design something like. So this was all about basics of comparable interface. And next day, I will take you to the next level, which is something about comparator interface. Anyone has any doubt? They can discuss as of now. Have doubts?
Yeah, no, Raju, I don't have any doubt. So it can be, we can reverse the long sentences as well as a string in this, or okay. Because it was taking the alphabetical order
Yes,
specifically.
alphabetical order and place by place. Means first capital, first small, then it will take in that order only. Numerical value it will take and then it will compare.
Okay. Okay, we'll try that. Okay.
So basic things you have already done, sorting and all such things, but this is something about custom data type. Comparable and comparator interfaces are for custom data type mainly.
Yeah, I mean, I was thinking this is another where we can reverse the string as well with long sentence. So
you can give a try. It's like you can have any doubt, then you can give a try with your own self.
okay.
Creativity is like you can do. Any level is up to you. You can sit on internet and you can explore some of the examples that where we can use comparator in comparable interface. So as of now, we have just discussed about basics about comparable interface. First, I have shown you that if you don't use, then you cannot do the sorting on custom data type. Then the importance comes, right? Then why was the news of there was a need of comparable interface. Then it told that, okay, if you want to use it on custom data type, so you can write it like this. And after that, the collections.sort will understand that you have used it. Okay. If you are not using like this, this will do a compilation error. But once you have implemented and you have overridden the compare to method, then you can use it here, line number 34. So custom data type sorting can be applied on any fields, but the restriction is that if you are using comparable interface, so only one field at a time. The main drawback is that means if you have 10 fields, then only one field you have to opt that which field you want to do the sorting. That's the main drawback of comparable interface.
Okay.
Okay. I hope it is okay with you, everyone. Chitti Babu, Vipra?
Yes,
Okay?
Raji.
Yes, sir.
Okay, you can explore the video, like go into depth, like if anything. I think
Yeah.
once you watch the video carefully, you will understand more that how I have tried to implement and why there was a need of comparable interface, because normal sorting we could have already done on integer and string data type. So custom data type sorting when it is needed means on a particular field. Custom data type means you can have multiple fields and any one of the field if you want to apply sorting, then you can first apply the comparable interface and then in the implementation part means where the main method is there, you can implement those logics. Okay. Okay then. Thank you.
Okay.
Okay.
Yeah, thanks, Rajiv, for your time. Yeah, thank you.
Thank you. Thank you. Have a nice day.
Yeah, good night.